Well, hello there. It's Mrs. Chalk coming to you on Easter Sunday. I'm sorry I have to miss tomorrow, but taking care of my dad and taking him to the doctor is very important. So let's get to this lesson. I'm going to go a little bit fast. If it's too fast for you, good news. You can pause the video and re-watch it. So let's get started. Mean absolute deviation, part one. That means there's going to be a part two. One way to describe the variability, or another way is the spread out of a set of data is by using mean absolute deviation. Mean absolute deviation is the average distance, the average. So you're taking the averages of the distance that the points in a set of data are from the mean. So you're going to have to find the mean, and then you're going to take the average distance. It'll all make sense. Well, what does deviation or deviate mean? How can I help you remember the definition of mean absolute deviation? Well, deviate means to depart from, to go away. This could help you remember absolute because you're getting away from the mean. How far away are the points from the mean? That's what you want to know. Let's just kind of go to the how to do it. The first thing you do, so there's steps. As long as you follow the steps, you'll be fine. Okay. So step one, you're going to find the mean of the data. And I've showed you how to do that on Desmos. Okay. Then you're going to find the distance from each data point and the mean, okay? And then you're going to find the average, which we know it's almost like we're doing mean again. It's like you're doing the mean and you're doing the mean again. Anyways, we're going to find the average of those distances, okay? So let's take this step by step, okay? Find the mean. Again, I've showed you guys, come to this little pretty page. I got to move that. Pop up the calculator, go to mean, and pop in your points. So our points are 61, comma, 68, 63, 67, 70, 62, and 64. Okay, so I know from just doing that my mean is 65, right? Now, stay right here and you're going to see why, okay? Keep this right here, okay? So my mean is 65. Then you list the distance between each point and the mean, okay? So how far is 65 from 61? Well, it's 4, right? How far is 65 from 68? It's 3. So we're going to get a whole new set of data to find the mean of, okay? So how far is 65 from 63? It's 2. How far is 65 from 67? It's what, that was 2. Sorry. Wait. 61, 68. Oh yeah, there's 2 2s. And then how far is 65 from 75? How far is 65 from 62? 3. And how far is 65 from 64? 1. So now we have a new set of data. Now we're going to find the average of that data. So I usually just do it straight from here. If I know the mean is 65, now I'm going to do mean again, okay? And I'm going to go 61 from 64 is 4, and then 3, and then 2, and then 2, and then 5. I lost my place where I'm at. To 70 is 5. And then to 62 is 3, and to 64 is 1, right? Okay, did I get all that right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, there it is. So my answer is, and it says to do it to the 10th, is just going to be 2.9. 2.9. 2.9. Okay. So what that means, what the mean absolute deviation represents in this situation. Okay, what this was is a police officer recorded the speeds shown on the right for the last 7 drivers that passed by the highway. Okay, this is the average of how fast they were going. Okay, so the mean absolute deviation is 2.9 from, so it's 2.9 from the mean. So they're either 2.9 less or 2.9 farther. The speed from the mean is 2.9. That's our spread. Okay. So that's as hard as it gets. Let's try it again. Let's try it again. First, find the mean of the data. Okay. So we're going to come right here. If I went too fast, I'm going to show it all to you again. Let's find the mean of the data. So we have, oops, my phone came unplugged. Okay. So we have, this is a bigger spread. This has a much higher range. So we've got some outliers here. Okay. Let's go. 4, 33, 58, 11, 28, and 64. Okay. So I know my mean, my average is 33. Now let's take the MAD of that. Here's how we get the MAD, the mean absolute deviation. So 33 to 4 is 29, right? And then 33 to 33 is 0. And then 33 to 58 is 25. If you need to use the calculator down here, you can do that. 33 to 11 is 22. Yeah, 22. And then 33 to 28 is 5. And then 33 to 64 is 31. Okay, so 18.7. So let's write this in here. So we're going to write over here 33. And the distances, our new data is 29, 0, 25, 22, 5, and 31. Okay. So then what did we say that this was? 18.7. Now let's explain what that data means. So the ages of several patients in the waiting room at a doctor's office are shown in the list on the right. Okay, so this right here is the ages. So we've got a good spread. Okay, the average distance at each is from the mean. So the mean is 33, and the average distance from that is 18.7. Pretty easy, right? Did any of this seem hard for you guys? This is as hard as it gets. Well, part 2 might be a little bit harder, but no, it doesn't get much harder than this. So your turn to try. Okay. I'm not going to give you the answer. I'm not going to give you the answer till after the fact. So I'm going to say, okay, you do number 3. And then I'm going to put little questions up. And then I'll give you the answer. Okay. Find the mean of the data. The mean is 32. Did you find it? Okay. Now, can you do the distance between each data point? So you're going to make a new set of data. You make your new set, and let's see if you get it right. Okay. Hopefully you got 11, 6, 15, 12, and 10. Okay. So what is the mean of that to the nearest 10th? Okay, I'm hoping you got 10.8. And then explain what the mean means. Let's look at the question. The number at the right represents the number of minutes that it took Diana to get to work each day this last week. Okay, so in her spread, the MAD is 10.8. So her average is 32 minutes, give or take 10.8 minutes. That's what we're saying. Her average is 32, give or take 10 minutes. So it could be 10 minutes less or it could be 10 minutes more. That's basically what we're saying. Okay. Dominic sent the following number of text messages each day over the last week. Find the mean absolute deviation to the nearest 10th. So they're not breaking it apart for you this time. So the first thing that you have to do is you have to find the mean. So find the mean. Okay, I'm hoping when you found the mean, you got 89. These two right here really skewed that data, didn't it? Okay, now find the MAD, mean absolute deviation. And you should have gotten 43.4. Okay. And so what we're saying is on average, he sends 89 texts. Is that what it is? He sends 89 texts, give or take 43. That's basically what we're saying. There's a lot of variability. Lots of variability. Okay. Mrs. Pritchard found the mean absolute deviation for test scores for her first period in math. The mean absolute deviation was a very small value. Very small value. Preston is Mrs. Pritchard's first period class and assumes that this means that the class did not have very high test scores. Do you agree? No. No. It just means that all the kids, mad means the students had close scores. The students had close scores. That's what that means. Okay. I want you guys to summarize today's lesson. This is actually going to be part of your thing. Remember, when you're summarizing, I want you to say, today I learned ... For example, ... So there should be at least 2 to 3 sentences of what you learned. Okay? And then with the time remaining in class, you should be able to put together this riddle because this was a very short lesson. You have plenty of time. I would like you to put together this riddle. And actually, I think I'll put it on the Ed puzzle that you need to be able to tell me why the student scared the average teacher. Why was the student scared of the average teacher? Let me look at the answer. Oh, it's a good answer. Okay, So you should be able to do this. And I'm going to have on the Ed puzzle this question. Okay. Love you guys. I wish I was in class today. Actually, if you're watching this in the afternoon, I was in class. I'm just being weird, but I'm not there in the morning. Okay. Bye. I hope you had a great Easter.